from DB 2019. A particle of mass m is projected upwards from a surface of the earth with initial speed 100 meters per second squared. So at t0, phi equals 100 and your s value is also 0. The air resistance to the particle is gv squared divided by 100 newtons per unit mass. So it has to be multiplied by the mass as well. Find the time for the particle to reach its maximum height correct to one decimal place. Alright, so force equals ma. Force is negative because we're going to take 100 as positive going upwards, so the deceleration is negative. You have gravity acting downwards, which is mg, and you also have your m air resistance to the particle, mgv squared over 100. So ma is going to be minus mg minus mgv squared all over 100. Okay, so next thing we're going to do is we're going to get the a on its own. So we're going to cancel the m's. Okay, and I suppose we could change at its maximum height, phi equals 0. So I think we'll change a into dv dt, and we'll have minus g minus phi squared over 100. Okay, so far so good. So what next thing we're going to do is take out minus g. Oh, sorry, there's a g there as well. And what we might do is might give them a common denominator of 100 as well. So I might change that into minus 100g over 100. Okay. So I might be able to do something with this here. So what I'm going to do is I'm going to take out minus g over 100. And what that should leave is, it should leave me with 100 plus phi squared. And that's what the vdt is. Next, we can bring down the 100 over phi squared. So it's going to be dv, bring this 100 over phi squared underneath. So it's going to be 1 over 100 plus phi squared. And then bring the dt up. So it's minus g over 100 dt. Okay. So we're after the following items. So what I'm going to say is it starts off with 100. Velocity starts off at 100. This is at t0. I'm going to put t here. We know the velocity is 0, but for argument's sake, I'm just going to use v just to have it as a general equation when I need it. Okay, so how would you integrate this? Well, I believe this is going to be tan inverse. So it's basically 1 over 10 squared plus phi squared, which would be tan inverse phi over 10. So remember, tan inverse x over a, it's 1 over a tan inverse x over a when you integrate 1 over x squared plus a squared. So what we're going to have here is 1 over 10 tan inverse phi over 10, and that is going to be from phi to 100. Okay, I might slot in the v equals 0 yet because it might just make my life really easy. Good to have some of the workings done. And then we're going to have minus g over 100 t, because you just have to, it's just a variable. This variable is basically a constant, and then you just got to knock in the t beside it. Okay, and that's from t to 0. Now, when we multiply this out, this is going to be minus gt over 100. No bother. And what I suppose we can do here is we can put in phi equals 0, because we know phi is going to be equal to 0 anyway. So it's going to be 1/10 tan inverse 0. And we all know tan inverse 0 should be 0, we're hoping. Tan inverse 0 is 0. And then minus 1/3 tan inverse 100 over 10. Okay. So what we're still on here now is we got this here. So we got 0 minus 1/10 tan inverse 10 equals minus gt over 100. Alright, I'm going to cross multiply this. I'm going to get rid of the minuses first. Going to multiply up by 100, so it's 100 divided by 10. You'll see that in a second. 100 divided by 10 is 10, divided by g, and then it's tan inverse 10 equals t. Put that into the calculator. 10 divided by 9.8, tan inverse 10, shift tan inverse 10. Okay, our radians. Got to be in rad for this. Shift, setup, rad. There we go. T equals 1.501 seconds. Okay, and I know that's definitely the correct answer. Okay, so we got T equals 1.501. That's brilliant. .501. Find the maximum height reached by the particle. Okay, let's find this one out now. And pause. Okay, so what we now know is that T, we can calculate the maximum height. Now it gives a bit of a hint away at the start. See the V to V here? That's a bit of a hint of how we're actually going to take on this question. So I'm just going to go back to the start here. So I'm just going to rub all this out. And we're going to do 10 part B now. And what we're going to say is that instead of using the V to T, we're going to use V to V ds. Or you can use the V dx. Depends what way. We used S earlier, right? So what we're looking for, S is the height at phi equals 0, and at phi equals 100, S equals 0. So that's our plan for this one, okay? Because it's giving us an interest in, it's showing us how to integrate this equation. So where we were at the very beginning was we had we had A equals, was it mg? It was mg, so it was just minus g, and then it was minus gv squared over 100. Okay, so what we might do once again is we might just give a common denominator of 100 like we did last time. Now instead of using the v dt, we're going to use the v to v ds. Okay, because we want the distance. We have the limits up the top here. We're going to do 100 top and bottom like last time. So it's actually going to be 100g over 100. What is 100g over 100? Okay, we're going to take out minus g over 100, and we're going to be left with 100 plus v squared on top. I'm going to change that 100 into 10 squared, and what we can see, it's starting to mimic what we're looking for up here. And then we have v to v ds. Now I'm going to cross multiply stuff down here, so it's going to be v divided by 10 squared plus v squared dv, and it's going to be minus g over 100 ds. Now I'm going to look at this integral here. I'm going to copy and paste it down. So this is the integral I'm trying to have a look at. I have to use this information to integrate this. Now it had to give you that in exam because it's not meant to be, they're not meant to be using this because it requires substitution. So what we're going to do here is we're going to integrate from phi to 0, from 0, phi is equal to 0 at the end and phi is equal to 100 at the start. And this is equal to a distance of at the beginning the velocity is 100, the distance is 0, And at the end, it's the height is at phi equals 0, and it's phi over 10 squared plus phi squared dv, and this one is minus g over 100 ds. Now, we're going to use this a equals 10. So the integral of this is going to be a half ln, a is 10, so it's going to be 100 plus phi squared. The plus c doesn't matter because we have limits, so there's no plus c involved there. And this is 0 to 100. And this one here is going to be just minus gh. Oh, sorry, we forgot about s. So minus gs over 100 from h to 0. And this is going to be... It's going to be minus gh over 100. And on this side, we're going to get a half ln 100, because that's what that one is, minus a half ln 100 plus 100 squared. Now, I'd be inclined to lob all that into the calculator straight away. Get me a nice... Doesn't say I have to have the answer in any specific form, so ln 100 minus a half. No point wasting time rearranging it and making it look fancy. Plus 100 squared. This should be a negative answer, we're hoping. There we go, minus 2.30756. 30756. Now g is minus 9.8 over 100 equals h. So get that answer, multiply it by 100 and divide by 99.8. Multiply by 100 divided by 9.8. You can put a few dots on it if you wanted, and you get your maximum height was 23.5465. Because what you said was 100 multiplied by your answer, or just call it x even. You could have started as x in your calculator. 100 multiplied by x divided by 9.8 equals h. H equals 23.5465. Okay. Or 23.55 meters. Okay. Okay, so that's the 2019 question 10 part A.